In this video, I'll show you how to solve the ALEKS problem called Interconverting the Wavelength and Frequency of Electromagnetic Radiation. So in this problem, the equation that we're going to be using is C equals lambda nu. In this equation, C is the speed of light, and the speed of light is 3 times 10 to the 8th meters per second. Lambda is the wavelength, and it's the wavelength. In this equation, we want to use it in units of meters. And then this is our frequency. And in this equation, we want our frequency to be in units of hertz, which is the same thing as 1 over seconds or seconds to the -1 or per second. Sometimes it's pronounced. So in this problem, you are either going to be given the wavelength or you're going to be given the frequency, and then you're asked to solve for the other one. I have been given the frequency in units of megahertz, and I'm being asked to calculate the wavelength in units of meters. If you are given the frequency, the equation to calculate the wavelength is going to look like this. Lambda equals C over frequency. That comes from just algebraically rewriting the C equals lambda nu equation to give us that. And if your problem is the other way around, if you're given the wavelength and you're asked to calculate the frequency, that's going to be nu, or frequency, equals C over lambda. So you'll use whichever one of these equations makes sense based on what the problem is telling you. So like I said, I have frequency of 94 megahertz, and I'm being asked to calculate wavelength, which means I want to use this version of the equation right here. Lambda equals C over frequency. The speed of light is a constant, so it's gonna, C is the speed of light. You're gonna use this number every time, 3 times 10 to the 8 meters per second, and then you're gonna plug in your frequency from the problem, 94 megahertz. And we've got some weird unit stuff going on right here. So when we look at this problem, we want our units to cancel out so that we're just left with units of meters, and everything is all kind of chaotic over here. So look over here at these units. A hertz is the same thing as 1 over seconds, or 1 seconds to the -1. So what I can do is, instead of having hertz right here, I could have seconds to the -1, and that makes things look a little better, like at least my second units are matching up with each other. This is a big M, not the same thing as a little m. This is a mega. This is a prefix that's indicating the magnitude of this number. And so this is, these megaseconds aren't consistent with these seconds right here. So I actually can't use it in this form in this equation. I've got to take that 94 megahertz, and I need to convert that into a unit that is just hertz, or just seconds to the -1. So this means I need to do like a metric unit prefix. I'm going to erase this because this isn't going to work in this equation right here, and I am going to do a unit conversion down here. I want to get rid of my units of megahertz, and I want to convert into just regular old units of hertz. Mega is the prefix for 10 to the 6. So that means that 1 mega, anything, is 10 to the 6th of that thing. And so doing this conversion, my megahertz unit will cancel out, and I'll be left with 94 times 10 to the 6th hertz. And I know that's kind of a funny way of writing the number, because normally we want a decimal point right here, but it does not matter at all because we're about to do a whole bunch of math on this anyways. So I'm going to plug this form of the frequency into this equation, and this is way better because that way my 1 over seconds unit will cancel, and when I do the math, I'm going to be left with units of meters, which is exactly what ALEKS wants. So now we can go ahead and actually do this division. 3 times 10 to the 8th divided by 94 times 10 to the 6th. And I'm getting an answer of 3.19149. We'll just stop right there. The units are meters. ALEKS wants this to 2 significant figures, which means I can only keep these digits right here. The 9 means I need to round this up to a 2, so this is going to be a 3.2 for my answer.